I'm going to get going. Not too many people, but some people listen to the recording. So welcome, David and Dinesh. I'll start sharing my notebook. Let me know when you can see it.
Yeah, I can see.
Okay, so I think I'm still on basics, and this is probably a very long notebook, one of the longest in terms of what we've been through. It's been about two or more than two lectures that we've been at on just this notebook. Hopefully, we'll get to the finish of it, but there are lots of, because it's the basics, there are lots of functions that he builds up that he uses throughout the rest of his notebooks. So I think we were about at this point, even if there's a little bit of overlap, it's good to restart here. So, excuse me. So here he's trying to kind of define some functions which he will use for dispatching based on the types. So that's what he's kind of building towards the capabilities. So, for example, ARGName. So that's interesting in and of itself. Even in other usages, this type of thing comes in handy. So what he does here is just picks out any names that you pass into as arguments of a function. So he arg names, and then if you pass in f, the default for frame is false, then you get the attributes of the function. And depending on, and I believe this frame says, that is this a function or is this, I believe, I haven't looked at specifically frame, but um, it looks at different attributes depending on whether this is a function or a frame. And therefore, if it's a frame, then it uses f underscore code. If not, it uses dunder code, and it picks up the variable names of all of the arguments. So not just the positional arguments, but also the keyword arguments. That's why you do code cor count, and the plus is in addition. It's appending the core keyword only arg count. So it captures all of that and returns that. So for example, he's just doing a simple test here of if I'm giving argnames of f and f is x because he has defined f of x, then it should return that. Now, cast is a little bit more interesting. What it does, it's a decorator, and what the decorator does is it uses any of the annotations um, which are given to the parameters. So annotations are things like, let me show you, what you give it as the type to the parameter. So for example, um, none of these, let's see whether any of these have, none of these have type annotation. But anyway, if you have a type annotation, then that's what, here is one. So for example, here a colon int, and this int is what you're looking for as an annotation of a, which tells the function that the parameter a that you're passing it to it is of type int. And that's kind of what he's after. But in the case of cast, what's being done, if I can get to it, Sometimes my driver just freezes. Oh, come on. Sorry about that. There we go. Um, oh, I guess I need to run this function also since I missed it. So these are things we have looked at. It just we discussed this last time of what the annotations, returns, and stuff. But let me run this in sequence just so that there isn't any confusion. So now we are at with cast, and what this with cast decorator does is it's a decorator which uses any parameter annotations as if they were pre-processing functions, which means that if you give it an annotation, it actually runs this decorator and converts, that is, it uses the annotation as if it has to pre-process the function using those annotations. And what that means is something we'll just see in a minute. So let's run this guy again. So what that means is, let's say that we are defining a function underscore f where a is a parameter, b, if you see, has an annotation path, c has an annotation string, and d is just a default value of 0. But it has now, sorry, the function f then returns a boolean, okay? And this thing just simply returns a, b, c, d. So now when you do with cast of this function, that means you have used this decorator, and you then pass in 1 dot, string dot, and 3. So without staring at the output, what would happen is A gets the value 1. Now B is provided an annotation of path. Therefore, it's what it does is this decorator pre-processes the function with the annotation, which means it says that the decorator converts this dot, which actually the string dot refers to the current directory. And see what happens here is this string is converted to a path. That's what the pre-processing the parameter annotation means. It converts what you give it to a path. So it is as if it is pre-processing the parameters of the function with the annotations. And then because you give the next thing is 3, and now there's d already has a default. So this 3 is converted to a string. So it's again pre-processed to a string. So even though you give it an integer 3, it's converted to a string 3, as you see here, and the default value of d is 0. So that's what is returned. 1, path of the string, that is the string you pass in, is converted to a path. The integer you pass in, because it's the third element, is converted to a string, and the last value is default 0. And the same way you see 1 and dot. So now why does that work? Because a default of string is this, and a default, these two have defaults. So here you just say a is 1 and path of dot, and c becomes an empty string, and d is 0. So it is as if you apply the annotation, the parameter annotations, when you decorate a function with cast. Any questions?
Mm, yeah. So, uh, the path, the type path,
Mm-hmm.
is it defined in the it's predefined in a Python?
Yeah, yeah. The path is pathlib paths. So,
Uh-huh.
by the way, that's something, if you are not familiar, you should definitely look it up.
Okay.
I'll even
Yeah.
provide a link in Slack, but Python pathlib paths.
Partly part. Okay. So it makes sense, but let me go back to with cast. So in a sense, what the decorator with cast is doing here, because it seems to me like when we say underscore f a comma b colon path, so all the variables have the type attached already into it. Yeah.
Correct, correct. But
So,
what you,
so go
yeah.
ahead, please.
So the thing to clarify there is, in Python, the type annotations are not, um, how would I, what's the word I'm looking for? They don't enforce the type.
Yeah, correct.
It's just a hint. That's why they are type hints, right? So
Yeah,
if you provide something, that doesn't mean that it is that of that type.
yeah,
Okay. Whereas with cast says that you are now casting the type, you are doing it yourself. You're casting what is given into that type.
okay. Okay, so what does it mean is when we say decorator with cast, and then we say b colon path, now with cast has converted b into that type of a path.
Into a path type,
Suppose.
yes, into a path
Yeah.
like path. Or for example, simpler thing, let's just look at the string. Even though you're
Uh,
providing a 3 as an integer, it is converting it into a string. You
yeah.
see that in the first example,
Yeah. Correct.
right?
Yeah.
That would not happen if you didn't do with cast,
Okay. Yeah. Makes sense. Yeah. Thanks.
right? Because you have just, you say it's a string, but you've just provided it as an int. It will continue to be an int.
Yeah, okay. So I get it what you're saying, but just for my interest, I worked more on a SQL side, and then the procedural on a SQL. They do force the type of every argument. Why Python don't
Because
force?
Python was never, I mean, initially and continues to be not a typed language. It's, if
Mhm.
it's more a design decision in Python, it's, that's the reason it's so fluid and flexible and stuff. It's like more, you often say the type is from, if it quacks like a duck, it's a duck, meaning, it's, you infer the type, you don't force the type.
Okay.
So things can
Mhm.
morph type. So it's not a strongly typed language to begin with.
Okay. All right. Okay. Yeah.
So,
Makes sense.
this is being, so Python has provided type hints more to, that's why it's called a hint, and more to guide usage going forward rather than forcing it.
Right. Yeah. So it's your responsibility to
Right.
deal with it within the functions itself.
Correct. And in this case, because he's also using the type to dispatch and stuff, and if you want to be doubly sure, then you can do this with cast decorator, which
Yeah.
will then run a pre-processing, which basically says take all the arguments and for each of them, make it into the type, blah blah blah. That's what all this code does. Right now, I have
Yeah.
a
Makes sense.
question
Yeah. Thanks.
which again, I'm curious about. It's not must, but it's, to me, I'm also curious why he builds the dictionary using the reverse of the parameters. But not material to what actually happens, but I'm just curious why he does it this way. And if you see, he has done the reversed params, reversed f dot defaults or an empty dict. So I don't know why reversing this and then building the dict is important. And by the way, this dict zip is a fairly common construct that you'll see. So you zip multiple things and then you build a dict of it, which means the first one will be the key, the next one will be the value.
Well, reversing maybe needed because there is a standard order of positional arguments followed by keyword arguments and stuff. And maybe if you don't reverse it and don't start with keyword only arguments, it may cause some shift or something like that.
Yeah, that might be a good reason why he reverses. Okay, so that does that's what Witcast does. Then then he comes up with a store attribute which he uses in a lot of places. This is again a FastAI or a Jammy construct to simplify and make things you know uh, easier and fit it all in a screen. So before staring at underscore store attra, which he uses here, let's look at store attra. So what store attra does is it stores the parameters named in a comma separated variable names that you give from the calling context into attributes in self. So again, that seems like, let's run this in sequence and then let's look at an example and then come back to the um, details of the code, because that would make it easier for us to understand what the code is actually doing. So this is just a simplification that he implements so that he can define classes or class attributes, even function attributes, as we'll see in a minute, in a kind of dense manner, if you will. So with the store attra, so what is now in its basic form, what you do with store attra is you can just shorten the code. As I said, it's, this is one of the reasons he does it. So here, if you see, and even this is not typically the way you would write the code, you would write it vertically as def in itself abc, self.a is a, self.b is b, self.c is c. Of course, you can make it a single line and move it up so that it's condensed. So this is the typical way that you would define the init of a class, say T, right? But now once you have defined store attra that he is defined up above, then you could do this. Definite self ABC, store attra. Remember, this is, or if you recall, this is the string names. That is, you just provide the names of the attributes that you want the class to have all in a single string and you pass it self. Right? And it then creates the attributes for this class as self.a is a, self.b is b, self.c is c. So these two are exactly identical. Okay, so that's kind of what the store attra thing does. It enables you to write what you would typically write this way in cell 68. You can write it as in cell 69. And so, for example, you can just say T is, or here he's just using an example to illustrate. So T is T1, C is 2, B is 3. And that means A is 1, B is 3, C is 2. Right? And in addition to making self.a is A, self.b is B, self.c is C, it also does this, which is it stores the attributes in a dict called dunder stored args, which you can then use for display, logging, debug, whatever.
Just not. I remember that he changed this store author. You don't need to pass now the ABC. I guess only call the store author.
Yeah, he has that. Well, I mean, obviously, you'll need to. You don't need to pass self, maybe, but you will need to pass the attributes that you want to store anyway, right?
I think in the latest version, I don't know what he does inside, but I think it is
If
all
you pass
automatic.
no arguments, it stores all the arguments.
Yeah, that's there
Ah,
down below as well. Yeah.
okay.
Yeah, it takes all the arguments. If you pass it nothing and then stores them as attributes. Yeah, that capability is there even here. He's just building up to it, explaining it step by step. Yeah, so that capability is there built in to this as well. So for example, let's see here, since you normally want to use the first, see, slowly kind of takes you there, because earlier you were doing store ABC, comma self, but comma self is kind of the normal thing that you want to do. You don't even do that. So you drop the self. And that's an example he illustrates here. And then I think he'll eventually takes you to the case where if you don't give anything, then it takes the attributes from here and creates them. So this is just saying, this example is just saying that you can see C is not in the init, but if you define it within the class and then call ABC, it still does what you would expect it to do. So that's what.
Why he put the ABC in a single quote altogether?
Because that is how you pass it in. I mean, he just created. That's how the string that you pass in is what he uses to in the store attribute code to parse it into the attributes that it's stored in the class.
So if you go above, we were not doing separately before. So what we are saying is whatever argument you're gonna just pass all of them separated by comma and in a single quote.
Yes, if you
Okay.
look, for example, right here, he says store at ABC.
Oh,
And in
yeah.
fact, if you look at so now that we have an understanding, we can kind of look at this, right? Store parameters. So he takes the argnames. Argnames are the arguments passed to a function. So if this is, he kind of handles the self, either from the function or the frame. And then this is to deal with dunder slots. So slots is a unique case in Python. You can look it up, the details. But if I recall correctly, it doesn't store the attributes in the dictionary. So you have to kind of handle it as a special case. And then if store guard, blah, 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 he just makes this an empty dictionary. He gets the annotation, or sorry, if there is a casting involved, then you have to cast the annotations. Otherwise, it's just an empty text, and then gets into the code of saying, here is where he says names is re.split by comma star, which says you basically split the string that you pass in names and makes them into names, and then converts those names into the attributes. And then we'll get into an example of what the but does, which is, he stores attributes except those given in but. Okay, so that's kind of what the store attribute code does, and we can begin to understand a little better of what the code is doing.
Srinivas, what's the difference between store attribute and underscore store attribute?
I think he just uses underscore store attra in store attra. It's fairly typical of, see here, this particular, so here, see return, when he returns it, he'll return underscore store attra, self, the annotation, and the attributes. Now, underscore store attra does the actual, it gets the attributes from self. Remember that he has mentioned that the attributes are stored in a dictionary, stored args, and so he actually stores the stored args itself as an attribute of self, and he gets he gets that attribute and all the or he gets the attributes of he gets the stored args attribute of self. The default is none. If it doesn't exist, puts it in stored, and then because it's the attributes dot items, which means all the keys and values, he passes them to then get the attributes. So that's this code, and then he eventually calls this code after he builds the attributes dictionary right here, where you can see it's the last line, and then he calls store attra self anna star attributes, which he passes here to then get back the actual function that store, or not get back, but to actually store the attributes as you would want them to be stored in the with their names, with the appropriate values. So this is fairly typical of, he just uses the underscore store attrib function in the store attribute function to perform the task.
Okay, thanks.
So here again, if you see casting, right? So he's not using the whatever the with cast or whatever decorator, but he's casting them. So when you cast and you say cast is true, then what is happening is these attributes will be pre-processed with the annotations that you provide, much like with the decorator. So for example, let's say now you define, remember that store attra ABC cast is true is different from default, which is cast is false. T is T1, C is 2, B is 3. You will see that A is listified. And if you recall listified, if it's not already a list, it converts it to a list and sticks the element in it. So you can see 1 is converted to a list. That's because cast is true. So it's listified the 1. And it's also converted C that you supply as an int to a string. That clear? What it's doing?
Yeah.
Explain
what
here.
It is doing. Yeah, what it is doing is clear, but where it is doing that the casting itself, where it's enforcing it, that the A
in
is
the store
now
attribute.
listified.
Now let me just run this and then we'll go back. I don't know why I'm having difficulty.
Oh, so store it. Okay.
Yeah, it is in store attra. The code is there in store attra.
Ah.
I don't know why it's misbehaving a lot today, but if it returns me the, hopefully starting next week I'll be on my desktop and not on my laptop. I'm back but still in quarantine, so I can't get access to my desktop yet. Okay, now it should be back. So now let's look at this. See, where is cast? Must be cast. Cast is false. Here. Anno is annotations of self if cast, else it's just an empty dict. And the annotations of self will actually convert, and if you go up and look at annotations, it will actually apply the annotation to each attribute in self. So that's how you cast. So if cast, so if it is not cast, then it's just an empty dict. You don't do this pre-processing. If not, you do the pre-processing. So this line is what gets you the cast false or true to take effect.
Yeah, thanks.
Right, so, okay, so this is where we saw that casting, with the help of casting. Then this is also interesting. You can inherit from a class which uses store attribute and just call it again to add in any new attributes in the derived class. So the point is that you could have defined a class which, like we did with for T is already defined using store attra. And then let's say T2 inherits from T, you can have an additional attribute and you can still use store attra within the derived class. So that's so that you can use inherited classes and still use store attra. Right? So T2 is inherited from T and you still can do it. And then we get to what David was talking about. And this code does what you were saying earlier, David, which is you can say, now you see here, and this was also what Arto was referring to, class T, def under init self ABC, just say store attra. This is cool. Then it picks it up from ABC and puts it in there. You see? I think this is because I get all these differences and stuff because I run it before to go through it, so I understand it myself, and then when I run it again and if I do anything different, it seems to constantly complain, which is pretty annoying. So you see this guy here is class T def init under init store attra, which is kind of the what David was talking about and what Arto pointed to as well, that you can actually not even give it the string if you want all of the attributes to just show up, which is pretty cool because you can just define it the way as long as you have all of the attributes that you want. So about that, I'll look into why it does so much of difference saving. The next thing is just with keyword args, store attra, it also adds the D, which is for the keyword arg that you've added in T4, sorry, not keyword args, but the additional attribute, I should say, that you've added in an inherited class. Here, if you see, you do not have D. So the class T only has attributes ABC, and then you inherit and add an attribute D in the init, and you just say store attra, it picks up this D. So you have actually stored only ABC by using this store attra, but inherited class T4, you do T and you can define a store attra and it does that. Oh, geez. Then comes the usage of but. Give me a minute as it reconnects. There we go. So let me rerun this guy. Okay, so if you look at it here, class T4 is 3, TA is 3 and TB is 1 because you have defined a default of 1. T is T4, A is 3, B is 2. It's just checking that it's doing the store attribute things correctly. Then he has a check which says make sure that it works subclasses, which means inherited classes work with and without store attra correctly. That means, even if you did not provide a store attra, then it should still continue to work. And then this is an interesting variant that's supported in store attra, and which is you provide it with a but, and the attributes which are provided within but are skipped. So we'll look at that in a minute. If you look at it here, so self ABC store attra but equals the string A, which means you want it to store B and C and not A. So that's kind of what you want when you use the but parameter within the store attra. So for example, let's say T class has 1, C is 2, B is 3. So you've kind of stored values in C and B, but there is no attribute A, even though you've initialized it with ABC, but you're storing the attributes and saying but A, which means it doesn't, the class T is created, but without the attribute A. So that logic will again exist in the store attra code, which says if there is any split the strings that you're getting in but, and then make sure you don't have an attribute with those names in the class. And then you can also pass keywords to store attra, which is identical to setting the attributes directly, but also stores them in understored args. So this is different than if you recall, this different way of passing attributes into store attra, right? Than passing in a string. So you can also pass in, is saying another way of passing in attributes to the class is to pass in keyword arguments to store attribute. So various things you can do with stored attribute, right? Just to quickly off the top of my head summarize, you can kind of give it a string which will split it and store those attributes. You can say, you can give it a string. You can also give but equals another string, which means the string split from but will not be stored as attributes. Then you can just say store attra and empty parameter value, which means it'll take everything in it and store it as attributes. You can pass in keywords in store attra, which then will get converted to attributes. So you can do all of those different things with the store attra function that he has built up. Various different ways to simplify the attribute creation in a class. And this is also interesting, although I have seen him use the store attra a bunch of times in various notebooks. I don't know that I've seen him use it in a function. So if somebody finds it and would like to share, feel free to bring up an example of its usage and share with the rest of us. He's building up, let's say, create t, and then it's just a function, create t, parameters a and b, and t is just a simple namespace. And within that, if we can say self is t, return this t, then you can build the, or he then creates a simple namespace t. See, t is a simple namespace. It's just a namespace, and then you store attra self is t, return that namespace, and then you say create t is 1 and b is 2, then that namespace has the attributes a and b in it. Has anybody seen him use this capability in the notebooks? I have not noticed usage of that, where he uses it. Okay, moving on, then attradict is essentially dict from each k in these k's to get the attribute k of O. So that's essentially, he just builds the ability to get all the attributes. So far, remember, what we've been doing is storing attributes, not getting them or accessing them. We've been storing attributes onto a class or a function. Here, it's attradict is creating a dictionary of attributes. So k get attra OK, whatever value is default for every k in case. So that's what this code does. So for example, after you've run this code, which is store attra, obviously from what we know now, ABC will be stored as attributes. You create a class with this, and then you get attradict of t and then b and c. Then you'll see that it builds a dictionary with b is 3 and c is 2. Right now, the next thing he does, and I've seen him use this capability a bunch in one particular notebook. I'll try and find it and share with you all next time, is kind of defining properties, again, with the interest of saving, making code dense. So he defines properties in a class, and what he wants to do is whatever you provide in PS or Ps, he wants to stick them as properties within this class. So he wants to make the attributes in P, for each attribute P in PS, you want to make the P a property of the class. So change attributes in class with names in Ps to properties. That's what it does. So for each P in this collection of Ps, you set the attribute class P and you make it a property getter of class of P. So that's how he makes P a property of this class. And we have kind of in previous discussions spent some time on properties and why and how they are different from just attributes and so on and so forth. So this is just a mechanism to get the list of attributes you provide or the collection of attributes provided in Ps to be properties of the class. Right. So for example, the next cell is an example of where he uses it. Let's say you have two attributes A and B, just returning 1 and 2, but you want to convert one of them to a property. Then you just say properties TA, and you check that T dot A is 1. And because A is a property, you can just call it as an attribute and it will return that. If you recall, that was the what properties help you to do. Whereas since B is a method, you still have to call B.
So A could be a property as well as method?
Properties, if you recall, are methods converted to be attributes.
And could you remind me, in a sense, let's say if we have a method.
Right. So the reason, if I recall, one of the reasons, I mean, there is other things. Properties are also, you don't directly change. They are kind of like getters and setters in other languages and stuff that you use property for. But one of the things that you also use properties for is, or one of the reasons you create a property and use it is because an attribute, if something else changes, the attribute doesn't change by itself. Obviously, if some underlying thing changes, then a method, because it is a function, will change because it will rerun the method with a new value. Those are among the things we went through when we looked, I think, maybe 4 or 5 classes back at the details of property. I think Rekil took us through some couple of examples through as well. So the short version of that story is that you can access, here A is actually a method, if you see, and but when you define A to be a property, then you can access it as an attribute of the class rather than as a method of the class. So here you see T, I mean, an instance of T. You could always have also done T, small t equal T, and created an instance, but he's just creating an instance here and then accessing A as a property. And the fact that it's a property is clear because you can access it as B. If you try, because you could access it without the call to the method. If you tried that with B, it wouldn't work.
Correct. Yeah. Good. Thanks.
Okay, and then this is something just convenience, but also I think he does use it multiple times. Is the camel to snake case conversion. So camel case is exactly what this example shows, right? Capital small, capital small. So like a hump of a camel. Whereas a snake is all small and then connected with underscore. Okay. So that's what a camel case is, what you see here. A snake case is something that you see all small letters connected to each other by underscores. So using regex, okay, come on, run. And then, so what he's doing using regex, if you're familiar with, is regular expressions. He's just converting um, one. He's converting the camel case to all lower, and then connecting. So he's converting camel RE1, which is this guy, where he converts everything, I think, to one underscore. He connects the field in one underscore field two name, and then he uses that and converts all of that to a lowercase. So that's how he's able to convert camel case of what you pass in to the snake case. I think I ran that. Let me check. No, I didn't. Okay. So that's just simple. You can see what he does here. Class are camel, and what happens with that is the fact that wherever a new capital starts, it sticks in an underscore between class and R and camel. So it converts class R camel to class R camel, which is snake, because it's all lowercase connected by underscores. But this is camel because it's like, capital letters at C, A, and C. And then if you want to, camel to snake of already snake, it just makes already, it will make it small, the underscore will remain, and then snake it'll drop the capital letter. And then obviously you want to build the capability to go the other way. And he uses it because in a couple of cases, when he's converting from uses class to some other conversion and stuff like that. So snake to camel is make a snake case, camel case. So you split and then make things title wherever the split is. And title just means convert to a capital case, the very first letter. So for example, snake to camel of A underscore B underscore CC will make it A, capital B, capital C, and then a little c. Okay. And then class to attributes. Sorry about that. So here he's using what he has defined above, return the snake case name of the class, and then strip the ending class name if it exists. So he does camel to snake, substitute f class name, and then self dot under class name or class name dot lower. So you'll see what it actually does by using it rather than. So let's run this and then let's use it, because that's more illustrative of what this line of code does. So let's say you define a class, you define a property name, and then here you're saying return class to attr self of, and the string you're given is parent. So, and then you define two subclasses which inherit from parent, child of parent, parent of child, both of them in parent, child of, both of them inheriting from parent. Define a instance of parent, an instance of child of parent, and an instance of parent child of. And then, so when you do p dot name, it will just be parent. and you can see that it's converted to snake because it's dropped the P of parent, which is capital P. Instead, it's parent. Then test equals cp.name. Cp is child of parent, and child of parent will be child of, actually it would have been child of parent with C, O, and parent capital. But because of, drop this last class name thingy, it says child of, and it drops off the parent. And then test equals cp2 name does the same thing. But again, I have not seen, while I understand what he's doing here, and interest of completion, we go through it, but I haven't seen where he actually puts this to use. This is getaddress. Now there is a getaddress in Python itself, but this is his, I guess, version which doesn't work for a single attribute, but can be used for multiple attributes in a class. So it gets all the attributes. So get attributes, O star attributes, and then you give it a default. So what it does is it builds a list of all the attributes for every attribute in attributes. So this is where it gets cute, and you have to remember all this. And if you're building it yourself, I think you would, but it requires some familiarity, because what exists in Python is getaddress without the S. Getaddress is something he has built, which builds a list of attributes that you can get. So, for example, from fractions, import fraction, and then he says get address fraction 1, 2, and get the attributes numerator and the denominator. And it's kind of interesting. It will get you, because you have given it the attributes, you will get 1 and 2 as, or the attributes numerator and denominator are 1 and 2. So the fraction stores the first value in a numerator attribute and the second in the denominator, and you're able to get access to that using getaddress. So as I mentioned, this is kind of his basics notebook. So he builds a tremendous number of small functions that he then uses throughout the rest of his notebooks. Now let's see whether we'll. Okay, and then again, similar thing. Hasatra is a Python function. Hasattress is something he has built. So, and this means O will have all of these. He's checking to see whether the object O has all of the address in address. Whereas typically you'll do hasatra something in a single value, which means that you're checking whether the object O has the attribute attra. In this case, you're checking all has attra, O attra, for attra and attras to be true. And all obviously means all and any will are handy built-ins in Python. So it checks that all of the attributes exist in O. So he says, for example, has address of O is imagined and real, it exists, and then make sure that one doesn't have the attribute foo. So it's assert not has address one, imaginary will be there, but foo won't be. Then the next Nothing. Nothing. Has gone wrong. There we go. Okay, so same thing with set address. So in the destination, the attributes you want to set are fields. Let's see, source. So you get dict, you execute dict.get if the source is a dict, otherwise get the attributes. And fields, you split whatever is in fields, and for each element in fields, set the attributes field in destination, and the default is the field you get from source. So let's see how, let's actually see some test cases to understand how this thing works. So D is a dict with A is 1, BB is 2, ignore is 3. O is a simple namespace, set attribute O, A and BB, and you pass in the D. So D is the source, A and BB are fields. Then what you do is you get the from the dict, which from the source, the fields. So the fields are A and BB from D, which means it says 1, BB is 2. And you check that O dot A has been, O dot A is 1 and O dot BB is 2. Right, so that's kind of what set address does. Now, if you recall, so yes, get address, has address, set address, which are all kind of like the duplicate versions of get, set, has. Without the s's already exist in Python. And then simple namespace, set address, OA, BBT, test this. This is just a duplicate of the previous one. And then try address. Let's see what that does. So it says return the first address that exists in the object. Wow. Okay. So it basically says if it doesn't exist, trace an attribute error. But if it does, get the first address that you find. Again, very unique thing. I don't know where he uses it. So basically, it says, as soon as you find an address that exists in object, return that to me. And if none of the address exist in object, then raise an attribute error. Okay, so a lot of attribute manipulation capabilities. Store address being the major one, and then has address, get address, set address, try address, bunch of them. These are things we've gone through already in attribute delegation. So I'm going to skip over them because we have already gone through it. But by the way, editorial comment, if you're running this notebook, be aware for some reason he has stuck getaddress here, whereas he uses getaddress in a test up above. So if you want the test to pass, you need to come and run this before. I've been too lazy to completely move this above where he uses getaddress in the test case, but just so you're aware. And this is probably because he moved the whole attribute delegation from fundamentals to the basics notebook, but he may not have gone and re-updated all of that to get the sequence to work correctly. Okay, now this is something which is interesting and which is quite, he uses that quite a bit in the notebook, but this is just how he builds that capability, which is show print. And essentially, if you recall, and when we used the notebooks and went through the data-oriented notebooks of FastAI, we saw that he used the classes capital INT, capital float, and the difference between the small int, small float, and capital INT, capital float was the fact that the capital INT, capital float classes were capable of showing themselves. And how that happens is through this kind of class and inheriting from it. So this show print class basically has a show method within it. So which essentially says show of self args keyword args is just print string of self. So it just ends up showing whatever, it ends up printing itself. So that's the basic capability he codes in the show print class. And then he inherits from that class for a capital INT or a capital float in order to make that capital INT and capital float and capital string capable of showing themselves. And this is useful when he's running decode and stuff. If you recall, when we instead of encode and decode kind of goes through the show until it finds a show method. So that's kind of where these things come in handy. So you can see that the capital int is just nothing other than a classic int and a mix-in of show print. That means it is also in multiple inheritance from int and from show print. And because it inherits also from show print, I mean, there's no need for a code. It just is capable of showing itself because it has the show function defined within it, within the class it inherits from. Same thing for string and for float. So that's how he builds the capability for capital int, capital float, and capital string to show themselves. Any questions? I think we are getting closer to the end of this very long notebook that we have been at for 2 or 3 lessons now. Okay, let's look at what a few other things that, oh, he has the collection stuff too. Okay, let's go through that. Come on, I thought you were able to save. What's wrong? Okay, thank you. Okay, so this is where he illustrates what an int, capital int, is able to do, because you can call the show method of capital int, show method of capital float, and the show method of string, capital string, right? And they result in showing themselves. Right? And another group of functions that he creates is collection functions, which are already built into Python, but then he modifies them and to suit himself and to suit the functionality of data science, if you will. So, for example, there is detuplify, which is interesting. If X is a tuple with one thing, then you extract it. And that's what detuplify does. And that does come in handy, especially because he's using tuples a lot in the dispatch and in transforms. So that's why he makes or creates this detuplify function. And rather, I mean, you'll understand the code better if we actually look at examples. and then come back. So it basically, if the tuple has a single value, it takes that value out of that tuple and provides that. Don't know why the page saving unresponsive thing is such a problem today. Okay, there we go. So detuplify. Basically, let's look at what detuplify. When it's an empty tuple, it just returns, it extracts none because there is, obviously nothing in it. In this case, when you say detuplify, the list one, which is within the tuple, it just extracts one from it. And then when it is a single list entry into a tuple, it extracts the list 1, 2 from it. And then if it's a single NP array inside of a tuple, but again, remember that this is a single element numpy array within a tuple. So it extracts the entire numpy array. The array itself has 2 elements in it, but it's a single numpy array that's stuck in the tuple. So it extracts that. That's kind of what the detuplify does. And the reason, as I said, in detuplify, and you can kind of go back to the transformation code in whatever notebooks and look at the usage of detuplify, and you'll kind of understand why he needs that functionality. Replicate is just make the create a tuple of as much as the length of match times the item. So we have seen this match kind of thing in, I think, Listify as well, where he's using match to when he specifies match, he's actually using the length of match. So that's what he does here as well. Basically, replicate means make this item as long as the length of match is and put it and give back the tuple. So if T is of length 2, then replicate 1, 2 T will replicate this list 1, 2 twice. And you can figure out same thing with the next example. Then we have seen listify, we have seen kind of tuplify and detuplify, and now we see setify, which is nothing but make an object into a set if it's not already a set. So there, though, the interesting thing he does is he makes it into a set, but he first listifies the object O. So important, remember that listify has some of these interesting things where it takes stuff and sticks it into a list rather than just making it into a list. So you should look at listify code if you're not familiar with it, and then converts it to a set. So if we look at setify of none, it's obviously an empty set. Oops. Whenever I get, okay, and then string ABC is converted because he uses listify, which means he takes this string. If he just did a list, then this string would get split. So that's why listify doesn't split it. It just creates an element and then sticks it into a list, and then you make it a set. And because it's the only thing in the set, it's obviously that string exists as itself. In the set. So then now you see this 1, 2, and 2. That is converted in Satify to just a 2 element. So because there's a duplication of 2, because it's a set, it drops that. And the range is just that. Satify of already a set is just 1, 2 set. Okay, so I'm not going to run that, but let's say, oh, this is an interesting one, merging dictionaries. So how do you merge them? You merge them to this line of code. That is, if for every dictionary in the Ds, if the dictionary is not empty, then for each k and value in d dot items, you make k colon v. Now, the only thing in this that you need to be aware of is obviously any, I always get this confused, and hold me, check whether I'm saying the right thing. If I recall correctly, later values will override earlier values. So you need to be careful if there are duplicates. You need to be aware of it, of how it works. Because it is for every D in DS. So if you specify a later dictionary with the same key and a different value, that will override an earlier value, if I'm not mistaken. But that's a way to merge. And I think he might even show it here. Yeah, here. So you see in the second case where a dict A, B2, dict B3, 4, and you're merging, then you get B's 3. So you get the value from the second dict because you're doing it in order for D and D's. Obviously, if you want to override the first one, then you just reverse it. And you need to reverse. Well, actually, I think it would be good. It would be good enough if you reverse this, I think. Okay, and then range off is something he uses quite a bit. It actually is just list range length. So that's what the range of. So he uses, I've seen him use this, and it's a handy function as well, because you very often, at least in the, when you're generating indices and blah, 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 you need list range length of X. And he just creates range of X to be that, which is fairly handy. So for example, range of this is just, and usually I find this handy when you're generating indices from some object, for indices for some list of things that you have, because then you can generate the indices. Another handy function that he does, and actually I agree with him that this group by is somewhat easier to understand than the group by that is default in Python. So he defines this group by. There is a group by in Python as well. I think it is in, forget now, where is it? itertools. Okay. So like itertools.group by, but it doesn't need to be sorted. It is not lazy, which means it doesn't only work when it converts it actively, and it has some extensions. So for example, so what is this? Again, I think it's better understood with the code, but let's just quickly go through this. So if key is an int, then you get an item getter. Now remember, item getter itself is something that he builds. And if it's a string, then you get attribute getter. For the values, again, same thing. If it's an int, you get item getter of val. If it's a string, then you get an attribute getter, because basically what he's doing is, if it's an int, then you do the item getter because you use it as an index to go get the item. If it's a string, then you know it's likely an attribute, so you get an attribute getter. Use an attribute getter, I should say. So that's all he does here, sets it up to get an index or an attribute, and then builds, just initiates an empty dict, and then for O in X, you just set default key of O, empty list, append the value of O into this list, and then return that. So what does that code actually end up doing? So test equal group by, let's see, this string. So it's a string and you're grouping by. So what, and then you say it's string dot split. So what that does is it takes the first value because, sorry, let me explain this better. So you have a string split, which is your X. So X is this guy here, a string which you're splitting. What is the key? The key is item getter 0. That means, remember, item getter is an index. So index 0. So index 0 of the split of the string. Now, when you split the string, you get a list with each of these three things because you're splitting on the space. So you'll get A, AB, and BB in your list. And you want the item getter 0 to be your key. That means you want A to be your key. So if A is your key, then your values are, these two get grouped because both of these, AA and AB, have A at the index 0. So you can see the string A will have 2 entries in the values, and that's why this is a list. And you can see in that list are 2 values, A and AB. And then for B, you have a single entry BB. So that's what group by helps you to do. It helps you to group the items based on the key that you provide. And the key can be an index or the key can be an attribute, depending on what that guy is. Any questions?
Yeah, I missed the second part. So it's say when you split AA, AB, BB with the item getter 0. So item getter 0 is the index, which is your A.
Correct.
So how did he build the AA comma AB, the list?
Oh, this thing does it.
No, but
This line of code. For O in X, right, then the dictionary and set default key of O in this case is item getter 0. So key of O will be our A.
Yeah.
To that you append value of O. So value of O in this case will be AA and AB. Because when you have a key index, key is this, but the value is item getter of val. And item getter of the val will give you this two element list.
Okay. Okay. Yeah. Okay. Yeah. Thanks.
Okay, so that's kind of what group by, and group by, the Python group by definition is a little more convoluted than this. I did look at it some time back, but I haven't looked at it recently. I wish I had pasted it here so we can contrast and learn from that. But here is an example of how to invert a grouping using int as key, which uses item getter. Passing a string will use attribute getter, which I've talked about, right? Meaning if it is a index, you want an item getter. If it's a attribute, then you want attribute get string, then it's an attribute getter and using a val function. So let's look at this. D is 0, 1, 3, 7. 2 is 3, 3 is 5, 4 is 8, 5 is 4, 7 is 5. Okay, so this is a dictionary with various lists. Group by OK for K, comma V in D dot items for O in the values. Jeez. And okay, so this is what you provide as X, and key is 0 and value is 1. Okay, so let's see whether we can make sense of this guy. If anybody already gets what's happening there and would like to explain, go ahead. But I'm going to slog through this for O in V. So that means V is D dot items. So it'll be these guys. And for O in V, that means for the values. So for each of these values, so 1, 3, 7, 3, 5, 8, 4, 5. Okay. And then O comma key K. So it means it'll be this and so for each of the values, and then the keys will be 0, 2, 3, 4, 5, 7. And okay. And then what are you doing? You're passing it by the key. Key is 0, so it'll become item getter. Okay. Oh, is it saying that 1 occurs in 0? Item 3 occurs in 0 and anywhere else? Yeah, and in 2, 4 occurs in 5. 5 occurs in 7 and 3. So at least you can see what the result is. The result is saying in which of the keys do these values occur, right? That's the result you're getting from this grouping group by. Is that at least clear? See, it's saying if you look at this one, which is a value, so for O in V, because V in D dot items, so this is here O, that means this guy 1, which is a value 1, in which keys does it occur? And it obviously occurs only in 0, right? So it sticks in the 0 in the list. Now, if you look at the value 3, it occurs for the key 0 and for the key 2. So you can see 0 and 2. Now, similarly, 4, the value 4 occurs only in the key 5. So you only have 5. The value 5 occurs for the keys 3 and the key 7. So you get 3 and 7. Then the value 0, let's see, is there a value? Sorry, the value 7 occurs in just the key 0, and the value 8 occurs just in the key 4. So I believe we have covered all the values. Is that right? Because we should have covered 1, 3, 5, 7, 4, and 8. 1, 3, 4, 5, 7, and 8. Yep. Ouch. That is interesting as to how you can build that. Is that at least what it's doing clear? Any questions? It's basically saying each of these values, in how many keys does it show up, and give me the result of that. That's what this group by does. So it's inverting the grouping. So it's saying, oh, now I understand what inverter grouping means. Basically, it says, oh, I have keys and values. Now for each value, tell me in how many entries in the dictionary keys do I occur. Which is kind of interesting. So you can flip the dictionary around if it's a bunch of lists of values for each key or a bunch of attributes for each string key. Then you can say, show me all the classes that an attribute occurs in. That's another, if instead of using a key as an integer, if you use key, these were all attributes, you could say, if these are class names and these are all attribute names, then you can flip it to say, show me all the classes where each of these attributes occurs, and you can use the same construct. Interesting. Then the last index finds the last index occurrence of X. Again, don't know where he uses it, but for example, last index 9, so it says that's because this 9 shows up at the index 5. And 6 doesn't show up at all, so it's a -1. Filter dict, so apply filter a dict using func applied to keys and values. So that means you apply the function to the dict and apply it to the keys and values. So func of kv, and then for kv in d.items, if this is true, then create that. So for example, letters is O, character O for O in the range of this. So then letters makes it, because character O is the function and it returns that. Okay, let's see, filter values. So filter values says filter dict, filter keys, filter values. So it does the same thing for the dict, where he applies the func to the key values of the dict. Then filter values is just applied to the values func of v. And then filter keys is just applied to the keys. I guess I haven't seen usage of these either. So if people see the usage of this in his notebooks and would like to share, let me know. We have seen at least that cycle is just a slight change in the cycle. Cycle exists, by the way, in iter tools, but except in this case, he modifies it to add the nuns if it's empty, which the Python cycle doesn't do. It can't handle nuns, but none, creating a list of nuns is useful in a lot of data processing type of things, which we are doing, obviously. So by data processing, I mean in data science, and that's in deep learning. So you could, for example, say cycle empty 3, that means you will get none times, you will get 3 none entries in a list. Right. So otherwise it's the same as iter2cycle. So listify, if you go back and look at the code, handles the none case. So once you have listified O, then you just call iter2cycle O. If O is not none, which is the standard usage of iter2cycle, and length of O is greater than O, that means you don't have a none case, else iter2cycle none. And if you look at so iter2.cycle and then a list having the entry none is how he enables the cycle to handle the case of having none values, as opposed to the default cycle, which doesn't support none values. Zip cycle is just you zip X with whatever arguments you're providing. So it is like itertools.zip longest, but cycles through elements of all but the first argument, which is interesting. So it kind of skips the first argument, but cycles through all of the rest. So for example, if you look at, well, let's run these. So if you look at this guy, it's a list of 4 elements and then ABC. Then zip cycle says that you zip 1, 2, 3, 4 with ABC, and then the thing it does is it recycles A, because you want it to zip for as long as the first element, value that you provide is. So this through elements of all but first argument basically means that you are cycling through this argument and for as long as your first argument. So you will recycle the second or argument to match the list, match the length of the first argument. That's kind of what you would do in this case. Okay, let's see. I'm still struggling, but we're close to end of time. Want to give a little break to people who may be joining the hands-on machine learning course. I think there aren't too many other functions that are all that interesting. If anybody has any questions on whatever is remaining in this notebook, feel free to message me on Slack. Starting next week, I'll move to the extras notebook. There is an extras notebook, and if that's short or if there is not much in it, then I'll move on to, I think there is a one other significant meta notebook where he goes into meta class and decorators and stuff like that, and that is fairly involved. So what to expect next week is extras notebook and the meta class notebook, and hopefully I'll be on the desktop and we'll be having so many sync page and responsive type of issues that we have had today. Apologies for that. Any questions? I think we're almost at the end of this. There may be a few others, but I think it's with about 10 minutes to go. I think it's a good time to end. Any questions?
No questions from me.
Yeah, no questions. Thanks a lot, Srinivas.
Sure thing. Okay, thanks everybody for joining, and hope to see you all next week on Express and the Meta class notebooks.
All right, see you next week.